Okay, in this video, I'll be taking you through as many as possible of the different types of data presentation techniques that you might be asked to either draw or complete for the Cambridge IGCSE Geography paper. And so these are questions that could appear on either paper 1, 2, or 4. So the purpose of this video is to go through as many different techniques as possible whilst giving you some pointers, and it's almost impossible for me to do all of the techniques to show you all of the different types of variations, but certainly it is possible for me to show you how to approach these questions. Remember, for some questions, for paper 1 or paper 2, they might only be worth 5 marks across the whole paper, yet for paper 4 you will have about 12 marks, or 20% of the paper, that is devoted to either completing or interpreting graphs. So it's really important that you practice and that you use this video to help you with that. When approaching these questions where you have to complete a graph or interpret a graph, it's really important you do not miss them. Sometimes they might appear at the top of the paper, and then the rest of the page is full of data, graphs, extracts, and so it's important you do not miss them. You need to think about the type of graph they're asking you to draw, work out the scale. If you're unsure about how to draw it or the scale, look at an example drawn, and copy exactly the labels, shading, etc. that have been used for the other examples. So again, it's a question that, although on paper is relatively straightforward, it's something that you need to take slowly and approach in a methodical way. So how to use this video. Once you have a past paper out in front of you, give it a go. Try first, maybe give it a go and draw it. Use the various chapters as detailed in the comments or scrolling along that take you to the actual particular skill, and then within that skill you can then wind forward accordingly to find the actual sort of graph or example that most applies to you. Okay, so let's start with perhaps one of the simplest, bar graphs. So the first question here is a simple question that usually asks for 1 mark. Use the results in table 1.1 to complete the horizontal bar graph of settlement B in figure 1.4 below. So we need to use the table 1.1 and we need to complete the horizontal bar graph. Okay, so we need to find the data from rent from city authority. So I need to scroll down to the bottom of that table, and you can see here I need to plot on settlement B, which is 42. So once I've plotted on that, and it's helpful that it's in bold, I need to check the scale. So 1 small box equals 2 percentage points. So, and also then I need to copy the pattern for squatter settlement B. So here it's all the way up to 40, and I'm going to draw an extra little to go just slightly over the 40 line, and so that gives me to the 42. And you can see here I've tried to copy the pattern with the fill, and so that is nice and straightforward there. Here you have to draw the bar graph again using a slightly different scale. So use the results to draw the bar for Eritrea in figure 1.2. So Eritrea is 6. First of all, I'm going to take my ruler to check the scale. So 5 migrants equals 2.5 centimeters. So 1 migrant equals 0.5 centimeters. So if I have to draw 6 migrants, that's going to be 3 centimeters. So I find Eritrea and I draw a line, a bar graph that is 6 centimeters tall. So again, taking it nice and straightforward, always checking the scale, using my ruler because they're always going to align, working out sort of the 1 migrant or the 1 unit be in terms of centimeters, and then drawing accordingly. Now this one requires taking the bar graph a bit further, and it's called a divided bar graph. That is when you have, say for example, a site, and you have lots of different reasons why people found that site attractive, or lots of different reasons why people want to visit a location, and so you have the total number of responses is the height of the bar graph, and you divide up that bar graph according to the responses to a question or various reasons. So here we have to draw what's called a proportional bar graph. So this is when you make up, so all the results have to make up, and you can see here on the left hand side for pull factors. What they've done is they've drawn a bar graph for all the pull factors, and so they've added on each layer on top. So remember, check the scale. So 2 boxes equals 1 reason, or for the number of, in this case, the number of migrants who responded. So the first one I'm going to draw is 14. So the first one, war and terrorism, goes all the way up to 14. Now the next one, and it's important to remember that these types of graphs are cumulative. So what I mean by that is 14 plus 7, so 7 is the next one, equals 21. So different, if I was to take 14 away from 21, that would give me 7. So racial religious intolerance would be 7, and so I'm going to add 7 on to take me up to 21. And again, I'm going to add 3 to 21 to give me 24. So draw that again. And then I'm going to add 1 more on to take me up to 25, and there's my results. So again, taking it nice and slowly. Remember that when you have a divided bar graph that's stacked on top of each other, it's cumulative, so you add on the numbers if you haven't already given the percentages, but even then it would still work the same way. And again, these types of questions are weighted quite a lot because you have to do a few extra calculations. Okay. So this is an example of when you have a divided bar graph that is done by percentages. But for this one, we have to draw on the last 2. So selling homemade and other informal job. So I'm going to check the scale. Remember, 1 small box equals 2% according to my scale on the graph. It's cumulative. So what I'm going to do is 26 plus 24 plus 9 is 59%. Okay, so that's for the first bit. That takes us up to the formal sector. Yep, that correlates. And so selling homemade, I'm going to add 22% onto the 59 to take me up to 81%. And then obviously 81 plus 19 for other informal job is 100%, and that takes me up to the end of the graph. Remember, copy the key exactly. I cannot use in the various settings on PowerPoint, but hopefully you get the idea now. So here we're going to go into another relatively simple graph technique, which is a line graph. And line graph we pretty much use to show change in the data. So often you might not have to draw the whole line, you might need to complete. And so again, it requires you to check the scale. So in this case, 10 small squares equals, or 2 squares equals 1 degree Celsius, or 2 whole squares equals 1 degree Celsius. Check the key to understand the pattern you need to use when drawing the line. So if I zoom in here, I'm going to plot the points on first, and then just connect the lines up with a thick line, and I'm going to draw in pencil and copy the style and size of the points here. Now, sometimes for this, we might be required to use an example, and although this is angled at a slope, again, it requires you to draw a line graph. So again, I'm going to look at what they've done. And so simply, if it's 0.64 velocity and it's angular gradient over 6, this one is simply find the 6 point and go all the way down to 10. And this one just simply shows you how you can connect 2 graph types together. So here I need to plot on both a bar graph and a line graph. So again, I'm going to do the bar graph first, and vegetation cover at 65. Copy the style there, and I put this in red so it stands out. And then I'm just going to do the number of plant species on the right-hand axis. So that's for the line graph bit at 3. And then I'm going to connect the dots. And that's how you combine the 2. So again, rewind, go through. Remember that here they've got 2 different axes. You need to work out which y-axis is for which data set. So in this case, vegetation cover, I use the y-axis on the left. And for number of different plant species, I use the y-axis on the right. Common with climate graphs and other things like that, they require 2 different data sets to be combined onto the same graph. And again, kind of like a line graph and a bar graph combines. Here, simply, I need to plot on the number of different vegetation species at site 10, and I need to copy that style exactly. So here at 10 is 4. And so it's just, when you get these kind of weird questions, it's just you remembering, right, what is the style, what is the scale, and copy the other examples. And so for the next type, which are pie charts, again, a bit like divided bar graphs or bar charts, a little bit difficult to do if you do not know how to do it, and it's something that comes with practice. In this one, I'll show you how to draw a pie chart with percentages. This is when you have something very simple like this. So here, the question requires us to complete the figure 2.2 to show the beach material 25 meters from the sea at beach X. So I'm drawing, and helpfully, again, it's in bold, the data highlighted here. So 40, 35, and 25. So if I zoom in here, I have to draw it for 40%, and helpfully, in this particular case, they've actually put the various percentages on for me. So remember, it's cumulative, adds up to 100%. So 40 plus 35 and 25 is 100. I'm going to draw the first one at 40%, copying exactly the key they have used. I'm going to add 35 to 40, that gets me to 75. And then when I add the 25 that takes me to 100. So again, once the percentages have been marked on, this question's actually quite straightforward. And always copy the pattern they have done. Remember, with the PowerPoint, I cannot do that, hence it's highlighted in red. Next one is when you have numbers and you have to maybe work out the angle of the degree to help you do this. So again, it's cumulative. So 12 plus 15 is 27. And again, they've put on the number of residents here and helpfully divided it up for you. And I'm going to add 18 onto that. So that takes me up to 45. And then you've got the last one, 50. And again, always copy the pattern they have done. Now in this question, you're required to work out the angles. So in 2017, 36% of Germany's electricity was generated from renewable energy and 64% from non-renewable energy. Plot this information in figure 4.1 and complete the key. So here, unlike previous questions, you haven't been given like a breakdown in the percentages, although you could work out maybe 0 at the top, 50% at the bottom, 75% on one side and 25% on the other. You could do that, or you could work out the angle. And this is actually quite a useful skill to know how to do. So for this, we need to plot the information and complete the key. So the first in the key is 36%, which is renewables. So what I'm going to do is do 360, because there are 360 degrees in a circle, and I'm going to times that by 36 divided by 100. So that works out what angle, that's the percentage of 360 is 36%. So that will give me 129.6 or 130 degrees. So using my protractor, I'm going to plot on 130 degrees. And once I've done that, I'm going to shade that in, and I'm going to complete the key with renewable resources. And then I'm going to complete the other part of the key, and again, shading in with the various colors. And if you can see here, for 2 marks, I've got the smaller sector plot on it too, and I've got my mark for plotting on correctly. So again, go back, look at how I calculated the angle with the information provided. Remember, in this case, it was percentages, so it had to be out of 36. But if it was, 36 out of 50 respondents replied yes, then I would do 36 divided by 50, whatever that is, and I would times that by 360. So take it nice and straightforward, slowly, and practice. So another technique you might be required to complete, or you could actually use in your own investigation, is what we call a Choropleth map. And a Choropleth map is when you colour in an area, a region, a country, a location with a colour based on a particular value, or based on a scale that you've predefined. So here, for example, you can see a map of Europe, excluding Switzerland and Norway, so the countries that were part of the European Union, and each region or province within that country has been coloured in based on their median age. And you can see the key at the top, and so each region has been coloured according to the median age and where it falls within that colour scheme. So over here, nice simple question, plot the data for Germany and Poland on figure 1.4. So the first thing you need to do when you get here is to identify the countries and identify the key. That key tells you either what shades or what patterns to use, and copy what they have done. So you must do that exactly. So for the first one, for Germany, it's 19, so that falls in between 11 and 20, and so we need to use these X's. Poland, on the other hand, is 8, and so that falls into the one below, 1 to 10, and so we're going to use that one, which is dashes, and so I'm going to dash Poland accordingly. And that's it. So just very simple, but it requires you to identify the key, the value that you need to do, and you copy exactly what has been done. Here I'm taking you through how to draw a scatter graph. So a scatter graph is when you want to show, you've got some points and you want to show the relationship between those points, and so you would plot them maybe with something on the y-axis, and that could be distance, it could be GDP per capita, and then you have the result on the left-hand side, so that could be pedestrian count or life expectancy, and you want to show the relationship between those two data sets. Sometimes the questions could be really simple, that you need to plot, in this case, oxygen levels at Site 5 in 2018. So you go to Site 5, 2018, 9.3. And again, by working out the scale, you can plot the point very easily. So here you've got 1 small square equals 0.1. And so just have to count up 3 from 9 to get to 9.3, and I would copy exactly the pattern they've done, which is just an X, and I've done that in red here just so you can see it clearly. And again, slightly more tricky here. So for B, but again, it's the same skill. Plot the wind speed measurements at site B on days 1 and 7. So 5 and 14 for site B. And again, they've helped you by putting it in bolds. And so I'm going to work out the scale. So 5 little squares equals 2 kilometers per hour. And I'm going to copy what they have done. So how they've put on the X and where the number is. So if I zoom in, and I've got the key at the bottom. My first one, B, is going to be slap bang in the middle, directly above B, and it's going to go halfway between 4 and 6. And then for 14, helpfully it's there, and I'm going to mark that into the middle. And again, when the values are the same on this particular graph, they put them either side of the line directly in line with B. Now, sometimes the question requires you to draw a line of best fit, hence here for 1 mark. And I think this is quite tricky for 1 mark, but follow these steps, because the first thing you need to do is determine the direction of the slope. In what direction is data going? Is it going north and increasing, or is it going starting high at naught and decreasing? In this case, it is decreasing, so I'm going to draw a negative trend line. I'm going to draw the line in the middle of the data, and I need to try and work out an equal number of points on both sides of the line. Although the dots, when I draw that line, need to be equal distance from that line. And I'll show you with an example. So here, I've tried to draw it in a negative trend because it's starting off high and ending at 1800 meters low. I've tried to draw it in the middle to allow an equal number of points on both sides. And here's another example drawing on the line of best fits. So again, I'm going to try, after I've plotted on wheat and I've plotted on olives, I'm going to draw the line following the negative trend because it starts off high, it's closer to naught, and ends down low, closer to 10. And I'm going to try and get an equal number of points on both sides. And this is something that for 1 mark is quite difficult, but perhaps you can link it into your other subjects like maths and science. So now moving on to a method that you probably see for river questions mainly. It's where you're drawing the cross-sectional area. So if you take the diagram here, you can see I've sliced the river, and essentially all I'm drawing is the black line to show the channel of the river. So for this question here, I need to draw the cross-sectional area of the river for site 2, and you can see here the examples of site 1 and 2. And so what I'm going to do is plot on the points, okay, using the y-axis. Plot the points first and then draw a smooth curve. So here we go. So I've drawn on the 3 points. I'm going to start at naught, connect the 3 points in a smooth line, and then draw it all the way to the end. I might shade the bottom as well at the end, copying exactly what they've done. Okay, and perhaps a difficult skill to learn and master, something that can come up on paper 1, 2, or 4, are triangular graphs. And this is an example of one here. Now here, this is a really nice example of how to complete a triangular graph. And they've been even very generous with this question because they've actually told you what lines you need to use when drawing this. They've told you which angle you need to do the primary, secondary, and tertiary and plot them. Now what's it with a triangular graph is that basically you draw 3 lines, and where those 3 lines meet, that is where you put your points. So here, we need to complete the table for middle income countries. So we need to work out the percentage secondary employment, and we need to work out the percentage of tertiary employment for middle income countries. So pretty much we need to do the reverse. Now for the first bit, we need to realize we need to look at the primary. And so we have that line drawn for primary that goes straight down for middle income countries. Okay, so we're reading it along the bottom of the y-axis because it's primary going up, and it's going straight up the top. So we got 30%. For secondary, we're going straight across. Again, we're going up the left-hand side, and we draw a parallel line across. And then for tertiary, we're going down the right-hand side of the triangle. And where those 3 points meet, that is our MIC. So we can say confidently that it's 25% for secondary and 45% for tertiary. Just to give you a quick hand, if you want to work that out for low-income countries or HICS as well, that's usually quite a good way to do it if there isn't a key, but I can show you that now. So in this question, you haven't been told how where the lines are and how you go about plotting it like you were in the previous question. You need to work this one out. And for this question, you need to plot the data of beach material at 25 meters from the sea at beach X. So if you haven't been told that, let's go through an example here. So I've given you one for 5 meters from low water mark. So 80, we know that's going straight down because that's in line with number 1. 15 is going up because we've got the shingle at 15, so that's going up across there. And then going across, we have 5 millimeters for pebbles. 5 is halfway, and we put that across. So you can see where those 3 lines meet. That is point 1. So we know that for sand, we're going down. For shingle, as we go towards the left, we're going up. And then for pebbles, we're going parallel across. So if I was to plot on 25, I'd be going 40, 35, and 25. And where those 3 points meet, I'm going to copy exactly the key. So I'm going to put a little X and the number 2. So again, go through some examples, the ones that have been plotted, have a go at plotting them, and that would help you practice those. And here's another example again. So let's go through an example here because I need to plot on site 1. So we've got 84 going up, 10 going across, and 6 going down. And so those where they all meet across with number 2s, with the 2-point meets, and so I'm going to plot that accordingly. So number 1 for 88, 12, and now 0, going straight down the line. And where those points meet, I'm going to copy exactly, rub out my lines, and where those points meet, I'm going to put a number 1. And that's a triangular graph. Not a common question, but when it does come up, usually worth quite a lot of marks, so please do practice these. So another one is when you have to draw proportional shapes and flow lines. So for this one, we're having to draw a proportional arrow. So basically an arrow that's shaped according to a particular key. So here we need to draw a flow line or proportional shape, depending how you look at it, below to show the number of residents who work in Bridlington. So we need to check the scale. So Bridlington, we got 6. So the scale is 1 centimetre equals 10 residents. And so 6 residents equals 6 divided by 10, which is 0.6 millimeters. And so what I'm going to draw is an arrow that is 6 millimeters long and across that way. Now, moving on, we need to choose the results to show the number of visitors coming from South Africa and Australia on figure 2.7. So what I have to do is copy the arrow of the group, a bit like a Choropleth map, and how it links in. So South Africa, it's 1, so I'm going to have the thinnest line, and Australia is 9, so that's the thickest arrow, so I'm going to copy that and the pattern accordingly. This one, again, sort of similar. It's like kind of combining the Choropleth map of matching up your data in the right group and drawing the arrow accordingly. And I could use my ruler to do this to make sure that the measurements of the height of the thickness of the arrow is correct. So for Libya, it's over 431,000, so that's the third size. So I'm going to go from Egypt to Libya, copying the direction of the arrows, and then for Jordan, slightly thinner one going across. And you can see here that helpfully they've been labelled for you. So here it talks about flow lines. We have to plot them on again, so I'm going to quickly draw that. So you should know you just basically have to match up the number according to the scale. But this question here is, why isn't it an appropriate method to show the results to question 2 in the questionnaire? Flow lines are really good. It shows you clearly how many people are coming or migrating from Ethiopia and India to a particular place. So it shows you the direction in which these people are moving. So it helps you show the numbers and the direction and where they have come from. Another method you might be asked to do is drawing isolines. And for isolines, think of it a bit like contour lines. They are points of equal value. So they might be isolines in terms of when you have to draw on pressure in weather data, or in this case, it could be lines of equal height on a map. So like I said, isolines are lines that connect points to the same value. Think contour lines for paper 2, they connect points of land that is at the same height. So here, I have to draw and complete the isoline that shows 200 pedestrians. Now, how will I go about doing that? Well, it's already been drawn for us, so I need to complete it. The way to do that is, if I take the point here marked in red, I've got 300 and I've got a point 106. If I draw a straight line, a faint straight line between that, I need to work out roughly where 200 is. And that's kind of halfway in the middle. And so my next point I'm going to do is, I'm always going to find 2 points that are above and below 200. So if I move across here, you can see there's 270 and 156. So I'm going to work out where 200 is between that. So once I've done that, I'm going to draw on my red X's, always plotting on points that are above and below 200. I'm going to draw on as many points as I have using either the thick isolines that have been drawn or the points of particular location. I'm going to draw those, put those on dots, and then I'm going to connect those with a smooth line. So again, it's a question that you will have to practice, drawing on, finding out points that are above and below the line you have to draw, and then working out roughly where you would find 200 between that. Again, similar question here. You need to draw on the isoline for the 13-degree line. So again, I'm going to find out, I'm going to plot on the various points because it's very useful. Okay, so I'm going to plot them, maybe write those on of the various so the points of their temperature. So here helps me a little bit more when I go to draw it. So once I've done that, then I know I'm going to put this on. So I put these back onto the bigger one here. So I'm going to work out where, for example, 13 is between 13.9 and 12.5, where 13 is between 12.5 and 13.6, where 13 is between 12.7 and 13.6, and so on and so on, and then eventually connecting those dots. Rubbing out all my X's to make sure I have a nice smooth line. And so we're moving on to bipolar, which is usually associated with environmental surveys. So check out my other video when it comes to looking at environmental surveys, but essentially you are plotting on kind of like a line graph onto this of the values. So it's really straightforward. So if you've got site B, I'm going to put +1, and again +1 because that's where it's been ticked, down to -2, -1, and then back across to +1. Copying exactly the key of the example that's been done before, and then I'm going to connect those lines all the way to the ends. And so you get a nice complete graph. Again, slightly different way of drawing it here. They've put this on a line. Okay, so they plot basically a scatter graph, and then I have to draw the average line. So I'm going to copy exactly the key, which is a slight thin bar, looking at the other examples of 10.6. Another method which can be used to draw environmental quality is what we call a radar graph, and there's an example for you there. So here, as you can see, what I've done is that they have to put on the values of recreation facilities. So I'm going to go from employments, and I'm going to go down to runway and roads, which is 15. So I put the line there, and then I go across to 20, because recreation facilities, and then joining those two dots all the way down to education facilities. So again, plot the points on the various different scale lines, and then connect the dots. Then we're moving on to weather data, and again, most of the weather data you're asked to draw is kind of mostly line graphs or something like that, bar graphs, but there can be a few ones. And again, I've got another video there, look into my channel, that talks about weather data instruments in a bit more detail, so please do check that out. But perhaps the main one that you have to do is what we do compass roses to show the direction of the wind or the wind speeds. So if we've got this example here, we have to draw on Albany of how it works. So we need to draw on the wind direction, which is south-southeast, and we need to draw on the wind's speed. So the first thing we need to do is work out the scale. So the scale is 3 centimeters, equals 15 kilometers an hour. So 1 centimeter equals 5 kilometers per hour. 1 kilometer per hour is 0.2 centimeters. So 12 times 12 kilometers per hour times 0.2 is 2.4 centimeters. So essentially, I'm just going to draw a thick bar line of 12.2 to 12.4 centimeters going down the south-southeast line. 2.4 centimeters, sorry, going down the south-southeast line. And that's how we would draw it there, copying exactly the previous example. Again, we've got compass rose direction for adding the number of days that the wind direction was from the south. So we count number of times that the wind came from the south. So you might want to highlight or underline. So we should have 4 days from the south. And then I'm going to draw the line from the south going down 4 lines. So there we go. looking at a bit like a radar graph, 4, moving it around, making sure it's down the right way. And again here, draw a bar graph on the compass rose, and then you need to complete the wind direction at site B in figure 1.4. So this shows of where it's coming from. So 4, I'm counting the number of days it blew from the west and the number of days it blew from the south. So for west, we're looking at, well, from the south it's 3 days, and from the west it's 2 days. So I've just counted the number of S's and the number of W's, and so I'm going to plot that accordingly, copying the scale that's been done for me. The final method is the tally. So for this, again, tally, really simple skill, number of dashes, and then you draw a bar to close the gate, or however you look at it. So you draw 4 dashes and then a diagonal one going across for every 5. So here, you work out how the tally is made. Okay, 4 lines and the 5th is diagonal in this particular case. And then you plot the points and copy what they have done. So for the motorbike, I'm going to do 10. For taxi, it's going to be 4. And for bicycle, it's going to be 3. And that's it. This one question is slightly different to a tally. So what they've done is they've pretty much, instead of doing like line and a diagonal one across, they've plot x's. So hx represents the number of values collected. So if we go to the bolds, I need to first work out the scale and plot the points and copy the examples they have done. So for example, you can see here at 15, it's 3 people have travelled that far. So I need to put 3 x's. So if I go up, so 21, I'm going to put 2 x's, 22, 1, 23, 3 x's, nothing for 24, and 1 for 25. So again, it's all about copying what they have done. So to summarize, it's impossible to go through all the methods of data presentation. It really is. I've tried to give you as many as possible that I've seen over the years. So my advice, if you're getting something that hasn't been done before, is pretty much copy what they have done. Look at other examples. Are there other examples of how they've drawn the data? Work out that first, and then copy what they have done using the same scale, pattern, shape, or whatever they've given you from the key. And practice, 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 practice through past papers. Do not miss these questions. They are worth collectively lots of marks on any of the papers, particularly paper 4. So do make sure you answer all of them and you practice these as well. Thank you for watching, and if you do like the video, check out my others and subscribe and share with your friends if you think they will also find it useful. Thank you very much.